Hello everybody. Today we will learn how to deploy a smart contract onto the Ethereum testnet goerli. So to do this task, we will use something called Hardhat. Hardhat is an Ethereum development environment which allows developers to compile, debug, and deploy the smart contract onto a testnet or mainnet on Ethereum alike. And Hardhat is super useful for us because it also helps install some of the boilerplate that is needed for the project setup, thus saving a lot of time and energy. So in this demo, I'm going to be using Hardhat. And by the way, about my setup, I'm in a React app right now, but you can use any framework that you like, and the framework doesn't really matter. I'm just in a React app right now. So let's get started. So let's install Hardhat right now. To install Hardhat, we just need to type npm install Hardhat. Note that you need to install a node first before you can run this command. So let's wait for it to install. Should take pretty fast. Okay, so it's finished installing, and as I said, Hardhat can help us set up some of the boilerplate that we can use for deploying a smart contract. So to do that, we just need to type npm Hardhat, and it will set up some of the boilerplate. This step will take a little bit longer. Yes, we want to create JavaScript project, enter, and then test deployment. And oh yeah, we have to delete this readme. Remember, I'm in a React environment, so it doesn't really matter. Let's just delete it, enter, and yes. So Hardhat is helping us install some of the boilerplates that we're going to use for the deployment stage. So let's wait. Hardhat has helped us finish installing all the boilerplate. They help you install the config file, some of the scripts, and Hardhat should have helped you install some kind of boilerplate smart contract, but in this example, for this demonstration, I'm just going to use my own smart contract. Basically, the smart contract is a smart contract that allows for minting an NFT, which is in ERC 721, and I won't go too much into about this smart contract, but it doesn't really matter. This is the smart contract which I'm going to use. So right now, everything is set up. All we need to do is to prepare for deployment. So to prepare for deployment, what we have to do is to go to the scripts folder, and there is a file called deploy.js. And Hardhat should have gave you some of this boilerplate code, but we have to make some edits. So first, you see there's a capital greeter and like there's a lowercase greeter. We want to change all the capital greeters to the name of our smart contract. So let's call it NFT mint. Basically just change it to the same name, mint, and then NFT mint. We want this to be lowercase, and then NFT mint. So basically, if you see a lowercase, just make it lowercase, and then if you see uppercase, just make it uppercase. And then you have to make this NFT mint because it's lowercase, and they want a console.log, so we just make this lowercase. Yeah. So this setup is done. This setup is just basically telling us which smart contract that we want to deploy. So the setup is done, and just maybe to make it more consistent, we can rename this, but in this demonstration, I won't rename it. So this part of the deployment is done, and the next step is that we need to do the actual deployment, deploy on a testnet. So the next step is the actual deployment. I'm going to deploy this smart contract onto a testnet on the Ethereum blockchain. The reason why I'm deploying this smart contract onto the testnet instead of the actual mainnet is because the mainnet, to do a transaction, you need to pay some gas fee, and the gas fee costs actual money, and we don't want to be paying any actual money. So we're just going to be using a testnet for this demonstration purpose. We also advise you to use a testnet for your project for the hackathon as well. So you can use any testnet that you like for doing this, but in this example I'll just be using the goerli testnet because the goerli testnet it's just personal preference, but the goerli testnet, because I use it because the other testnets are going to be deprecated anyway, so I'll just use goerli. So as I said, we still need to pay some gas for completing a transaction on the testnets, but you can just get the goerli ETH from a faucet. Faucet just basically sends you like fake ether. So let's go into MetaMask, and a reminder is to use a dev account, a test account, because you don't want to be using your real account for any of this stuff, any of the testing stuff, because later you need to export your private key. So anyways, let's just copy the address of my dev account. Make sure that you're on the goerli testnet. You can get it from clicking this button, and then you can see this testnet. If you can't see your testnet, maybe you have to go to settings, networks, and pick the testnet from here. But anyways, make sure you got the address for the goerli test network. Let's copy this address and let's get some fake ether from the faucet to cover our gas fee. Now that we have some fake ether into our goerli testnet account, what we have to do right now is to go to this site called infura.io. So infura.io is a blockchain node provider, and it allows us to connect to the other nodes in a testnet or the mainnet, depending on which chain you're using. So when you go to Infura, click create new project. I'm just going to select Ethereum, and the project name I'm just going to call it test deployment. I'm going to create this, and as you can see, when we create this project, they have given us an endpoint, an API endpoint, so that we can connect to the other nodes onto the goerli testnet blockchain. So let's keep this here, and next step is that we have to go to Etherscan. On Etherscan, they have an API key that we will use to verify our smart contract when our contract is going to be deployed onto the testnet. So to fetch the API key, I'm not gonna do it on screen because I have some other API keys and I can't show them. But basically, what you have to do is go to your dashboard and then click API keys, create a new project, and it's pretty self-explanatory from there. They'll give you an API key, and remember to copy that the same way you did for the infura.io. And then last but not least, we have to fetch the private key of our MetaMask account. This is because later we have to tell that this is the account that is going to deploy the smart contract. So this is also another reason why we have to use a test account, is because our private key, if someone has a private key, then they can basically enter our account without any password or username, and it's basically really important. Also, these two API keys and the private key are like super important, so that's why I just use a test account. And after this video is uploaded, I'm just going to delete these projects, so don't bother hacking into my stuff. So anyways, to fetch the private key of our test account, we click account details, and then we click export private key. We type in the password, MetaMask, confirm, and as you can see, here's a private key, and we will have to copy it. So now that we have the two endpoints and we have the private key, it's really important, and we need to store them in somewhere safe because it's our private key and our endpoints. So, and we have to use that in the future. So to store in a safe place, let's create a .env file. So we create a .env file, and then paste in all those endpoints. And I did this off screen, but in the end, it should look something like this. You have your RPC URL from the Infura.io to connect to the nodes. You have your Etherscan key from Etherscan to verify your smart contract, and you have your private key from MetaMask. So it should look something like this. And after you've done this, I actually forgot something. You have to go and run this command, npm install .env. So let's wait for it to install. And again, it's really important. That's why we're putting it in a .env file. But anyways, right now the .env file is created, and then right now the next step is the actual deployment. So we have to do some configuration with the deployment. For example, which account we're going to use, which wallet address we're going to use to deploy the smart contract, which testnet, etc. So the way to do that is to go to this hardhat.config.javascript file, and we need to add in like the .env lines, so then we can use the .env objects in this file. So we have to type require. Actually, we type const.env equals to require.env. These commands basically allow us to use the .env stuff in the hardhat.config.javascript, and then we type in .env.config. Now here is the part which we actually do the configuration. So go to module exports, and you see there's already an object of Solidity, and it's 0.8.9. This basically refers to the version of Solidity you're using in your smart contract. So in my smart contract, I'm actually using 0.8.14. So let me just change it to 0.8.14. It doesn't matter which version you use, as long as this number is the same as the pragma Solidity statement at the top. So you have Solidity over here. Now what we have to do is to pass in the networks. So we have to create a new object called networks, and then we need to pass in the network which you're using. So in our case, it will be goerli, and you have to pass in the endpoint we got from Vero.io to connect to the node. So process.env and make sure you have the same name as this RPC URL. So let's copy this RPC URL and let's paste it over here, and we type accounts, and we type process.env.private key. So basically a private key. Let's copy this and then let's paste it over here. So that makes sure that this is the account which is going to deploy the smart contract on goerli. And then we also need to put a comma over here and a comma on the networks bracket. And outside the networks bracket, this is pretty important, we have to type etherscan, create this etherscan object, and then we type API key, and it's the process.env.etherscan key to make sure that our smart contract is verified. And there we go. So the configuration is done. This is our Solidity version. This is the network that we're going to use, goerli. This is our RPC URL to connect to the other nodes of the blockchain. These are the accounts that we're going to use to deploy the smart contract, and this is to make sure that our smart contract is verified. And that's basically it. Now that we have everything set up, we configured our networks, we got a Solidity version, we got our endpoints and a private key. It's actually time to start the deployment. So we have to run a few commands. The first command we have to run is called npx hardhat clean. So after you run this command, nothing should happen, just like what happened just now. But if you had an error while doing everything, there will be an error popped up, and hopefully you'll be following along with this video correctly. So after this, it's time to compile smart contract. So we type npx hardhat compile Solidity 0.8.14 is not fully supported yet. That's okay. I can still compile it. Just it doesn't really matter. Now that our smart contract is finally compiled, we can finally deploy our smart contract onto the goerli testnet, and we can view on Etherscan. So right now we type in this command npx hardhat run, and then we have to copy the path of our deploy.js. So let's paste it here. After you pasted it, let's specify the network. So in our case, our network will be the goerli network. So we type network and then goerli. And if everything goes well, and if we've been doing everything correctly, this should work. So let's enter. Network goerli. Oh, it's because I made a typo. It's actually supposed to be li. So let's run it again. Let's wait for a while. And there we have it. As you can see, our smart contract is finally deployed onto the blockchain, onto the goerli testnet, and it will say NFT mint deployed to, and then this address, and it's actually because of this console.log. So anyways, there we have it. It's deployed to this address, this contract address, but we're not done yet because we still have to verify this smart contract. But first, let's copy this address. Finally, our smart contract is on the goerli testnet, and then let's paste it into Etherscan. Make sure you're on the goerli testnet network. Enter. And there you have it. This is basically our smart contract. But as you can see, when you go to contract, this tab in basically here, you see this is in bytecode, and it's not supposed to be in bytecode. It's supposed to be in, like, you're supposed to see the solidity code that you've written, but currently it's in bytecode right now. The reason why it's in bytecode right now is because our smart contract needs to be verified. So to verify a smart contract, there are a few more commands that we need to run. So let's go back to our terminal, our code editor, and then let's run npm install at nomic labs, nomic labs hardhat and Etherscan, and then let's enter. So it's gonna install that, and while it's installing, let's add this require statement in our hardhat.config.js. Okay, it's finished installing. So we have to add at nomic labs hardhat Etherscan, and that's basically it. And then now let's run the command npm npx hardhat, and then verify to verify our smart contract, and then specify network. Make sure I don't make a typo again. And then now we have to paste in the contract address of our smart contract. So let's copy this and let's paste it, and then enter. And if all goes well, it should work. And then now you see success. It has submitted source code for contract, and now it still needs to verify, but basically we're done on our part. So actually, let's just reload this page. It hasn't updated yet. Success. So we have successfully verified our contract on Etherscan. So if we go to this link, it's just basically the link with our contract address. Now when you go to contract, you see we have our code on here instead of the bytecode. We have our code on here, and yeah, that's basically it. So congrats for sticking along, and you have successfully deployed your own smart contract onto Ethereum testnet, and you have verified that smart contract. So the process that we mentioned in this video is the same for if you want to deploy your smart contract on a different testnet, or if you want to deploy it on mainnet, except you might have to pay some more gas fee. Anyways, that's basically it, and hope you enjoyed the video, and I'll see you around next time.